कितना सेकंड डिग्री टॉर्चर शुरू होता है डिसिप्लिन के नाम और हमारे स्कूल में बहुत डिसिप्लिन और lack of discipline तो अच्छे का फिर क्या वो नीचे का लिख रही है ये सर ये क्या होता है सैलरी तो ये दे रहे हैं और सिखा आप रहे हो तो ये किस बात के ऐसे दे रहे हैं
Hi, can you hear me? Can somebody confirm?
Yes, sir.
Yes,
Okay,
sir.
okay, we'll start in 1 more minute. But I hope that you were able to try the paper which I sent yesterday. and we will
Yes,
discuss
sir.
the solutions today. I know that the paper was, I deliberately set it to be slightly harder than the questions that we have solved so far, but that is just to give you an idea that how different ideas can be applied. Uh, because we are not just preparing you for the exam which is there for you, this entrance exam, but we also trying to prepare you for what is going to come in the next 2 years. Like wherever you get selected, and you will be studying for JEE, so you should have some idea that what are the various tricks that can be used to create questions of seemingly high difficulty, but really many questions have very simple concepts around which you have to solve those questions. So yeah, just to give you an idea about those things, and also to illustrate one point which I like to emphasize this every time, that you need to start thinking beyond what is the syllabus, right? Because often in school we are constrained to this concept of this is the syllabus for this exam, so these are the questions that are going to be asked. And I talk about this every time in every batch. I talk about this for a few minutes because this is a very important thing, that we are so accustomed to the word syllabus, uh, that we expect that nothing outside of this will come for the for that exam. But it is not like that. As and how you move to higher levels of education, you have to start thinking beyond just syllabus, because that is just a what do you mean by syllabus, or what is the curriculum? It is just a some set of ideas or concepts. So it is just some like uh, sometimes it is just facts, like this thing happened in this year, for example, or the chemical, the atomic mass of this substance is so much, or things like that. So facts and information is where it starts. Okay. But that cannot be the end point of your education. That if it is just about memorizing facts, information, formulae, then that is a very limited application. And I think you may already be seeing examples in the real world where we have automation, like we have software like ChatGPT, which can easily deliver this information. You don't need a human being to memorize facts, or even Wikipedia. So information, facts, just knowing this is not going to be enough in the real world. You need to be more smarter than that. Okay, so you need to learn what is called application. So what is the application of those facts?
त्यांचा
Like
व्हायला रे त्यांनी
how to take the concepts from those ideas, how to develop the knowledge from those, and how to solve real problems. So that is what application is about. And application cannot be defined in a syllabus. It has to be broader than that. That you want to apply those ideas in different ways. So that is why we are introducing you to different kinds of problems, that not just what is asked in the school exam, but what can be asked beyond school exam. That is the important part of application. Okay. And in fact, application is also not the end point. This is one part. You can go even further than an application, and what can be called research or innovation. Okay. So this is where you are really asking new questions, that some question which nobody has asked before, and try to answer that question. And you don't have to think that okay, I can only do this when I have my degrees, I have bachelor degrees, master degrees, where if I do a PhD only, then I can do research. It is not like that. It is a mindset. Even in the question which we are doing right now, every time I solve a question, I can ask this question, that how can I modify this question slightly to make it harder, or what other things can happen in this diagram. So those kinds of think to yourself every time you solve a question, because that is how you are going to expand your own knowledge, expand, help others around you. And ultimately this is required, as and how we are going forward. I mean, you are still at least many years from today when you will be still in your education phase, but eventually you will want to look for a job or something. So you want to develop the skills which are going to be useful not today, but 5 years from today, or 10 years from today. So you want the skills which are required tomorrow, not today. Okay. And keep all of those things in mind, that don't just become somebody who memorizes facts, information, formulae. You want to go from there to concepts, and from concepts and knowledge you want to ask new questions, try to innovate something of your own. Only then you can have a competitive edge. Otherwise you will be just one more person like lakhs of other people. And if you want to really use your potential, you have to do all of these things. So keep these things in mind. Okay. So regardless of how you do in one exam or other exam doesn't matter. So don't put all of your, I think there is a common proverb that don't put all the eggs in one basket. So don't rely completely on just one exam or one class. That okay, if I join this class, then everything will be fine. It is not like that. You have to keep thinking about all of these things, and of course, teachers are there to help along the way. But ultimately, you are responsible for developing your own knowledge and understanding. Okay, so yeah, keep all of these things in mind. Uh, okay, so I think from the last paper, I think we did one question about the convex lens, but one more question is remaining. But before I go to that, any doubts about the lens equation and what we did last time? If you want, I can quickly go over that once more just to make sure that everybody has understood this lens equation and mainly the sign convention, right? That as I keep emphasizing, this Gaussian sign convention is something new which you may have not seen before. So just to get used to that, we will solve problems today also to help you to understand this sign convention properly. So for example, if I look at this problem, the new problem, so we will try the same problem again, this new one using this Gaussian sign convention. Okay, so what is the setup? An object is kept in front of a screen. Okay, so there's an object over here and there's a screen and the distance is given and the lens is kept so that a sharp image is obtained on the screen. Okay, so there is a lens over here, let us say, and that is going to form an image on the screen. Okay, and they have said that whenever this kind of setup is there, your convex lens always produces a, if the lens is between the object and the image, then it will be a inverted image, right? And in fact, it will be a real and inverted image. So in this diagram, let us say we can use some names. So this length is u, then this length is 360 minus u, right? And the focal length of the lens we don't know. So let us call that f. So we'll write the lens equation again using Gaussian sign convention, right? And here I don't have to worry about the signs because this 360 minus u is positive, and the because this is a real image and real object, so everything is positive. So we don't have to worry about anything here. And in the second case, what is happening? The lens is moved to a new position. Uh, the object is still in the same position, and the lens is now 120. The distance between two positions is 120 centimeters. So the new position of the lens, if I denote it somewhere over here, then the lens was moved by 120 centimeters, right? So how much will be the new distance over here? This from the object to the lens, this will increase by 120, and the other distance will decrease by 120. So this will become 240 minus u, right? The total distance is still 360 centimeters. Okay, so now I can write the equation for this diagram once more. Everything is positive, so I don't have to worry about the signs much. Okay, so you see this is an equation with two unknowns. So in fact, I have two equations and two unknowns, right? So I can solve and get the value of u and f. So what we can do is we can simplify both of them separately. Uh, or actually, I can equate them, right? What the RHS is equal, so let us just equate them so that f will vanish, and I'll have 1 upon u plus 1 upon 360 plus u is equal to, okay, so for this I just need to solve for u. So let me just take the LCM and expand this. So I'm going to get here. Okay, so since the numerators are equal, the denominators will also be equal. So therefore, I'll get 360u minus u square is equal to uh, okay, and regrouping, and I see that u minus u square will cancel. So in fact, this is not even a quadratic; it is simply a linear equation in u. And so if I combine all the terms together, I'm going to get uh, 20. Okay, so therefore u is simply 240, right? And so if u is 240, I can put this back in, let's say, equation 1. So from equation 1, I will get 1 over 240 plus 1 over 120. So therefore 1 over f is uh, 1 over 80, right? Therefore f is 80 centimeter. Is that the right answer? Yes. Okay, so this, I think this was a more straightforward question than the previous one, because in the previous case we had real as well as virtual images, but here both images are real, so we did not have to do anything different. We could just get the answer directly. Okay. But as I said, firstly, if any questions about this? Again, maybe if somebody missed yesterday's lecture, you might be confused. How am I writing these equations? In the school, you must be familiar with a different equation, but just remember that in the Gaussian sign convention, this is the equation: 1 over u plus 1 over v is equal to 1 over f. And I will post a couple of links on our WhatsApp group later on if you want to read more about what is the basis of this Gaussian sign convention and some more examples about how to apply it properly. Okay. So what I was saying just now to you, that every time you solve a question, don't just move to the next question. Think more about what happened here exactly, and can you derive some more general principle that okay, here the value of u was 120, right? Sorry, what how was u? U was 240. Wait, actually, how can u be 240? Oh, sorry, u is 120. Yeah, exactly. U is 120, not 240. So in the diagram, if you see what is happening in the first diagram and the second diagram, what is the relation of the lens and the objects? So let me, if I draw the diagram to scale a bit more accurately. So U is 120, which means that it is exactly one third distance, right? So if the object is here uh, and the screen is here, and if I divide the region between them into three parts, then this was the case that the lens was here, right? And then uh, the image was formed, and in the second case, the lens was here, and again the image was formed. So exactly the distance was one third and two third of the full length. If I take 360 as my full length, then this was one third and two third. And the second diagram, it became two third and one third. So you see the sort of the the whole diagram got mirror image in some sense, that what was to the left became to the right, and what was to the right became to the left. So this kind of reversibility of the path of light is the property here. And then you can ask the question that in general, if I have any lens of any length, any focal length, when will the clear image get formed? So let me ask you this question, that okay, let us say the distance between the wall and the object, or the screen and object, is given as small d, and the focal length of the lens is f. Okay, then so the question is, find the positions of the lens where a clear image gets formed. In other words, you have to find the values. If I call this u and v, you have to find the values of u and v where the lens equation is satisfied. And so we have to check how many such positions are there, and is there any special relation in those positions, and see if you are able to find some interesting property about this. Okay, and so this kind of uh, you know And this was about a convex lens. What about a concave lens? What changes? And later on, we also have similar questions with mirrors. So every time, ask these kind of questions that uh, don't just solve the given problem. Try to find more interesting ideas. Okay, all of this is going to help your eventually your exam preparation. Okay, but anyway, so if this is clear, then we are done with all the questions from the past papers. So then we can move on to the practice paper, which I shared yesterday. And so let me start by sharing the answer key so that if you want to check your answers, you can tally them with this. I hope my answer key is correct. I have verified the calculations, but in case there is some mistake, let me know. Okay, and I will also post the answer key along with this PDF of hints and like one line solution on the WhatsApp group, so that in case you want to revise this paper, you can do it offline. Okay, but assuming that you have noted the answer key, let me start discussing the problems. So okay, okay, so question one. So anybody who has tried and solved question one, can you tell me how to solve question one?
Sir, can I speak?
Yes, go ahead.
Uh, so at T0, we
Mhm.
can draw the body at the ground
Mhm.
with going up with a velocity u.
Yes, okay,
Then we'll do the same thing for T1 and T2.
okay,
At T1, the body B will be just on the ground while A will be slightly up.
yes, correct.
At
And
T2, they'll be at the
Mhm.
same level.
Yes, correct.
So sir, at T2, a
Mhm.
displacement of body A will be ut minus 5t square.
Mhm. And how much is T?
Sorry, 2u minus 20
Yes,
after.
correct. Yeah, correct.
Same thing for if we do for B, we will get u minus 5.
Correct.
And
And we
since
just have to
A equate,
equate the two, right? Yeah,
yes,
correct.
sir.
Yeah. Okay. I hope everybody has followed this. I mean, I think this was relatively straightforward question that we just apply the same formula for both A and B. The only thing to take care is the B starts at t equal to 1. So B has been traveling for only 1 second. That is why in the second equation, the T is 1 and here the T is 2. And when you equate and solve, you get the value of U directly as, so you get 2U minus 20 is equal to U minus 5, or in other words, we get U equal to 15, right? Okay, so again, this is the kind of question which should be a time saver, that it should free up your time to do other questions. Any doubts about this one?
No, sir.
Okay. Okay, then question 2. Anybody who has tried and got question 2?
Sir,
No, nobody?
in
Yes, go ahead.
question 2, I just had a doubt. Is QR a
Yes,
straight line?
it is not a straight line. It is
It is not a straight
because
line. Okay.
no, because the question also says there is a constant acceleration of a meter per second square, right? In Q and R. So
Okay.
it is very close to a straight line, which means that acceleration is a very small number. As we will, when we calculate now, you will see that a is a very small number. So in fact, a is 0.2 meter per second. That is why there
Okay.
is only a slight deviation. Uh,
Okay.
okay, so how do we solve this question? So I would suggest that we can write two kinematics equations, right? So the path
Yes,
from P
sir.
to Q is with one acceleration of 5a. In fact, that is a deceleration, because as you see, it is falling down. So it is a deceleration, and from Q to R, it is an acceleration. Okay, so we should write the two equations separately. So for the path from P to Q, the total displacement, right? The displacement will be equal to plus 5. So again, we are assuming the sign convention of upwards is positive and downwards is negative. Okay, so starting from 0, the object has traveled to plus 5. So the displacement is plus 5 is equal to, and let us say initially we don't know the initial velocity at point P. So let the initial velocity at t equal to 0 bu meter per second, and again assume to be positive. And here also it looks like positive is the right choice, right? So here the equation for the first 5 seconds will be 5 times u minus half at square. And here the acceleration is minus 5a, right? So acceleration, because it is a deceleration of 5a, which means it is acceleration of minus 5a. Okay. So therefore equation will be 5u plus half into minus 5a into 5 square. Okay, so this is the first equation. So we can simplify this. I think 5 will get cancelled. So I'll get 1 is equal to u plus, and in fact it should be u minus uh, 25, 25 by 2a, correct? Because here 5 into 5 square. So there was total 5q, but one copy of 5 got cancelled. And so if I just rearrange this, I'm going to get u is equal to, or 2 is equal to, or let me just keep it this way. In fact, what I'm going to do is I will rearrange this as, therefore u is equal to 25 by 2a plus 1. I'll keep it this way. So that, and also what is the velocity at q? So what is the velocity? If I call it v, so v will be the initial velocity plus acceleration times time, right? So the first equation of kinematics. And so therefore the velocity will be u minus 25. So I know the velocity at q and I know the displacement up to that point I have taken. So now if I look at the second part, that from q to r, what is the path? So now this time the object is falling from 5 to 0, right? So the displacement also has to be negative. So minus 5 is equal to 5 times, that is the 5 seconds, times the initial velocity, which is v now. So initial velocity for the path, because I'm only considering QR as the path, so the initial velocity is whatever was at point Q, right? So 5v, and now this is an acceleration of a. So acceleration means it has to be positive. Okay? So therefore it has to be plus half into a into 5 square. Okay? And now here I can substitute the value of v from here. Okay, before that, again 5 is going to get cancelled. So minus 1 is equal to v plus half into a into 5. Okay, now here I can substitute the value of v from here. So I'm going to get minus 1 is equal to u minus 25a plus 5 by 2a. And then further I can substitute u from here, right? So this u can be replaced by this term 25 by 2a plus 1. So that's it. Now everything is in terms of a. All the other variables are eliminated. So do you see the point, the purpose, like what was the strategy used, that I want to eliminate all other variables. I only want to keep a. So every time I get a new variable, like I got u, I express it in terms of a. If I got v, I will express it in terms of u, which in turn is written in terms of a. So that is how everything can be converted to a. And like this is a general strategy that we want to eliminate variables wherever possible. And so now if I just how to solve this for a? So if I take this on the other side, I'll get minus 2 is equal to a times 25 by 2 minus 25. Okay, in other word, this is simply okay. So therefore I'm going to get, oh wait, minus 25. So therefore I'm going to get minus 10a is equal to minus 2, or in other words 10 is 1 over 5. Oh sorry, a is 1 over 5. So therefore A is 1 over 5 and we are supposed to write the answer of 1 upon A. So you see A was a very small value, just 0.2 meter per second square. So that is why in the diagram, the QR looks almost like a straight line because it is a very small acceleration. See, if imagine that there was no acceleration, then from the point Q, the object will continue to travel in a straight line, something like this. But because of that small acceleration, instead it has this slight upward trajectory. Okay, let me just pause for a minute if you want to write anything. But I mean, really, what did we apply in this problem? It was just the same thing, kinematics equation twice, once for the path PQ and once for the path QR. The only thing that you need to take care every time is the signs, that understand which is acceleration, which is deceleration.
Yeah.
So that was the sort of trick used in this. Sorry, अर्णव काय म्हणाला परत सांगू का? अर्णव काय म्हणाला ऐकू नाही आलं. I don't know. Maybe or no. If you are asking me to repeat, I will just quickly go through the solution again. So for path P to Q, see, pay attention to the signs once more. So this is +5 because this is displacement from P to Q, which is increasing, right? So therefore that this is positive. This is negative because this is deceleration. So the object is slowing down. Therefore this term was negative. Okay. And then simplifying, we got this equation. And then for the second half, the displacement was negative because now the object is falling from Q to R, but the acceleration was positive because now it is, it is accelerating, right? The speed is increasing or the velocity is increasing rather. Okay. And then solving, we got this answer. Again, as I said, I will post this PDF on our group. So in case any doubts are remaining, you can refer to the PDF for a hint. Okay, then going to the next question. Anybody who has solved question 3?
Yes, sir.
Yes, Shrish.
Sir, so since 5 centimeter is below the water,
Mm-hmm.
The volume of water displaced will be 5 pi r square using the pi r square h formula.
Yes.
And since the density of water is 1 gram per millimeter, its weight is basically its volume. So
Correct.
5 pi r square is the weight of the whole cylinder because that is the amount of water it displaced to keep itself up.
Yes. Okay. Only to that, I'll add that we need to add gravitational acceleration G
Yeah.
as additional constant. But correct.
Yes, sir. And now it's filled half with water now.
Mhm.
So the height to which it's filled is 10 centimeter.
Yes, correct.
So when you fill it with 10 centimeter, the amount of water, the volume of water you add is 10 pi r square.
Yes, correct.
10 pi r square G.
Yes, correct.
Because you add the, yeah. So
Yes,
now, just input 15 pi r square equals pi r square into some h, into some height. And that
Yes,
cancels
correct.
out and you get the height as 15.
Yes, correct. Yeah. Okay. So yeah, just to add some more explanation. So in the first part, what we did is we understand that the part which is inside, like submerged in the water, the volume of that can be because that is like a cylinder, right? So if I assume the radius is r, which is not given in the problem, but we can assume some radius r. So let us say I assume the radius is not capital R, small r. Okay? And the height is 5 of that cylinder. So the volume of just this cylindrical part which is submerged is 5 into, pi r square h is the formula, right? So pi r 5 pi r square. Okay, and then assuming that the density of the, because it is water, so the density is 1 gram per cc. But actually, even if you don't know the density of the liquid, even if you assume it's some like rho, doesn't matter because that density is going to cancel from everywhere. Okay, so the weight of the displaced water is 5 into pi r square g. and we know that the buoyant force is equal to this weight displaced. So like if I show the forces on the empty glass, so the empty glass has its own the weight due to gravity. So if its mass is m, the gravity will pull down by mg, and then this buoyant force fb, which is equal to this quantity, right? And because the empty glass is floating in water, which means that these two forces have to cancel out. So therefore I can write mg is equal to 5 pi r square g. Okay, and therefore from this what the g will get cancelled, and I know m is equal to 5 pi r. Okay, so this is what is happening for the empty glass. Now when we add when we make the glass half full, which means we are adding 10 centimeters of height to the water inside the glass. So now what is the result of that? That the weight of the glass has increased now, right? So previously it was the empty glass, but now what is the new weight of the glass? So again it will be the mass of the weight of the glass itself plus the weight of water, how much water was added, right? So new weight will be mg plus the height of this water column is 10 centimeters. So it will be the weight of that water. So that is going to be 10 pi r square g, right? Why? Because the volume of that part is 10 pi r square and multiplied by g. Okay, again here actually technically we should include the density of the liquid also, but because it is 1, we are ignoring that term. And again the glass is still floating in the water at some new depth, right? So if I say that new depth is d, okay, let us say the glass is now, the glass will sink a little bit, so it will be submerged more in the water, and because of that extra submerged area, so now the new buoyancy or new buoyant force, or I should say the now, I mean, it is the total buoyant force now, which will be equal to the volume of the submerged part, which is now pi r square d into g. And again, they have to cancel each other, right? The whatever is the new buoyant force, if I call it FB2, so that has to be perfectly equal to the new weight. So therefore, the equation I'm writing, this pi r square d into g has to be equal to this mg plus 10 pi r square g. And out of this mg I already know because I computed it in the first part, right? Mg is equal to 5 pi r square g. So I'll replace this by 5 pi r square g. And you see everything else is going to cancel, and I'm going to get d is equal to 5 plus 10, 15. Okay. And in fact, you'll notice one very interesting pattern here, that basically we added 10 centimeters of water and the glass submerged by additional 10 centimeters, right? Initially it was 5 centimeters down, and after adding this water, it is 15 centimeters down. So in fact, there is exactly like 1-to-1 relation between how much water you add and how much the glass sinks. That okay, you can actually write that if we pour 1 centimeter of water, when I say 1 centimeter of water, you understand what I mean, right? If the depth of the water inside the glass increases by 1 centimeter, then the glass also sinks by additional 1 centimeter. Okay, so that is very interesting to observe. So always what you will see is that the level of the, like if I draw the diagram a little bit more clearly, initially if I, let me just draw the side view. Okay, so the side view is looking like this, that initially the glass is looking like this, that this length is 5 centimeters. Okay, let us say I add just 1 centimeter of water, then the glass will sink down a little bit, and the glass has now this 1 centimeter of water inside, and now the new depth is 6 centimeters. But again, out of that, this is 1 centimeter. So again, if I measure from the surface of my water outside the glass to the surface of the water inside the glass, then this gap is still 5 centimeters, and that will always remain 5 centimeters. So even if you keep adding more and more water, so the glass has more water, but the glass is going to sink further down. So ultimately, no matter how much water you add, like until the glass sinks, obviously. So let us say now if I fill the glass with half water, so now there is 10 centimeters of water inside the glass. Okay. But now the level of the glass will sink to the point where again there is a 5 centimeter gap over. So therefore again total volume submerged is 15 centimeters. And ultimately when will the glass sink? When this will happen. So this is the last point where the glass is almost about to sink, that it is on the very edge of sinking. Okay, where now this is like 15 centimeters of water, and still there is a 5 centimeter gap at the top. Now after this, even if you add a single drop of water, what will happen is that the weight of, so now the whole glass is not submerged. So this is the sort of the maximum buoyant force that can be applied, right? The buoyant force is proportional to the volume submerged. So if the whole glass is already inside water, it cannot add any more buoyant force, right? So now if you increase the weight of the glass by even one more drop, the glass will be forced to sink. Okay? You can do this experiment at home actually. Take a bucket of water and put a transparent glass and see that this is actually happening. Okay, so I hope that this also helps to explain how the buoyant force works, like on a conceptual level also. Yes, Atharva.
So is this universal?
It is universal as long as the liquid you fill inside is the same as the liquid outside. Only then what will happen, the weight of the cylinder, the weight of the glass is increasing at the same rate at which it is sinking. But if you pour a liquid inside which is, let us say, heavier than the water, okay, then the glass will sink faster. So that again, so I'll encourage you to derive the general principle. But in general, my expectation is that if the liquid outside and the liquid inside the glass are the same density, then this will happen. Okay. Yeah, but that's a good question. So I mean, so you should ask this kind of question, that can I generalize this principle? When can I generalize? By the way, another reason why this works is because this is a cylinder. Whether if it is a, I didn't think of this question. Is it important that it has to be cylinder? What if it's a cone? So you can ask this question, whether if my glass is like cone shaped, and now will the same principle hold true or something else will happen? That is one interesting question to ask. Like you can try different shape. What happens with a cone? What if it's a cube shaped glass, like like a water, like a fish tank? So in each case, maybe something different will happen. So yeah, you can find out the answers to all those questions. Okay, any other doubt? Okay, then question 4.
Sir, I have a doubt about question 4.
Okay, yes, go ahead.
Sir, is a test charge always positive or always negative? Or is
It doesn't matter, because basically what happens, if the total like you are going to learn in 11th standard about the concept of electric field. Okay, so if the force on the test charge is 0, then whether it is positive or negative doesn't matter. The total sum total of the field at that point is 0. So if
okay, sir.
positive charge remains unchanged, then negative charge will also remain unchanged. Where it will matter,
Okay,
if the force field there is non-zero, then maybe test charge, like positive test charge, might get attracted to the right and negative test charge might move to the left. But so the only case where when the question is saying that the net force is 0, then you don't need to bother about the sign of the test.
Okay, sir.
Yeah, but yeah, that's a good point. Okay, so let me draw the diagram. So you have 4 points A, B, C, D given some way, and you are given some distances, but not all the distance, right? So AC is 6 and BD is 8. Okay, but interestingly, I mean, you don't know how, like, the distance between B and C is unknown, right? So the same diagram can occur in different ways. Like it could be like this, right, where B and C are very close to each other, or it can be like this also, right, where B and C are far from each other. So how much is the distance between B and C? We don't know. So we are going to call that X. Okay. Okay. And then what else is given? We have in the first case, we are placing a positive charge like plus kq coulombs here, and at C we are placing plus q. Okay, so both positive charges here. And so now if I look at point D, I want to check what is the like if I generally the convention uses, let us say a small test charge of plus q is kept here. Okay, and again you can change this plus q to minus q, it will not change the question, but let's say it is plus q. Okay, then if you write the, so here both will this q will get repelled by both the charges at A and C, right? But the net force is zero, which means I can equate them, right? So the first, how much will this charge get repelled by A? It will be the Coulomb's constant into kq into q upon distance square. So if this is x, then this is 6 minus x, right? And this is 8 minus x. Okay. So right now for A and B, the distance is 6 minus x square, and that has to be equal to the charge, the force between B and C. Again, it is a repulsive force of k into capital Q into small q upon x square. Okay, and here you'll see that this C gets cancelled. So you see why this test charge does not matter, whether it is positive, negative, or the magnitude also does not matter, because it is always going to cancel from both sides. And this is also going to get cancelled. Q is also going to get cancelled. So I'm going to get the equation k upon 6 minus x square is equal to 1 over x square. Okay, so this is the first picture, and in the second picture, again ABCD points are at the same position, but uh, now we have plus kq and minus q, and now we are measuring the total net effect at D. So let us say now there is a test charge of plus q over here. Okay, and now so what are the distances involved? So AC is 6, this CD is 8 minus x, so therefore total AD is 14 minus x, right? And so now if I look at how much, so now what is going to happen? AD will have a repulsive force, so D is going to get pushed away by A, and but C is going to pull it, right? So therefore again the forces should balance out. So if I write the repulsion by A, it will be Coulomb's constant into kq into q upon 14 minus x square, has to be equal to the attraction by point C. So C into, right? And again the all the constants will cancel, and you are going to get the equation as simply k upon, okay. So now basically we have reduced the problem to just these two equations, that we have two relation between k and x. So we have two equations and two unknowns. So hopefully we should be able to solve it. Uh, so the best way I would say is that let us rearrange this and write it as k is equal to something, so that then we can equate the two and just cancel variables. Okay, so now if I directly compare and equate, then I can write uh, k is equal to, in both cases, okay. And now I'm going to take the square root of both sides. But when we take the square root, if I have some term like if x square is equal to y square, and I'm taking the square root, I have to be careful whether I have to write it as x equal to plus y or x equal to minus y, because both is possible, right? From either of these, if I square it, I'm going to get this. So how do I figure out which of them we have to consider? So we have to look at the signs of both the LHS and RHS. But here, because of the diagram, like the order ABCD is given, right? So we can be sure that all of these terms are positive, like 6 minus x, x, 8 minus x. So all the four terms are positive here. So therefore, it is correct to only take the positive sign. Okay, so we can only consider the positive sign. And now we have to solve this equation for x, right? So if I cross multiply, I'm going to get, okay, let me do it step by step. Okay, so if I expand, so this is a quadratic in X. So if I take everything to one side, okay, and here I can see the factorization 12 into 2. So therefore X is 12 or X into 2. So therefore, please mute yourself, Ashwardhan. Okay. So you are getting two roots for this, X equal to 12 or X equal to 2. So now we have to go back and look at the diagram that which of them can be possible. So here in my original diagram, because what is X? Yes, Amruta.
Sir, as it not mentioned in question for condition first that net force on B due to A and C is 0, then why we doesn't conclude D in first condition? And also in second we have not concluded B.
No, I didn't understand. In the first case, what did we do? In the first diagram, we took that. So total net force on B is 0. Therefore, we equated the repulsion of. So what is this? This first term is how much B is repelled by A, and this term is how much is B repelled by C, right? So we are equating the two, and from that we got this equation. But
But
this is
sir,
not sufficient. Yes, go ahead.
but this is not given in question that net force on B due to A and C is 0. Then we can conclude D it in also.
See, what the question is saying that the net force is 0, and so far the only two charges kept are at A and C, right? So when I place a test, so the yeah, okay, I understand the confusion. The confusion is that when I place a test charge, right, it is not a permanent charge. It is just to test that whether there is any force here. And then when I go to the next part, so in the first part there is no charge at D, and in the second part there is no charge at B, because the test charge is like it is only there to test. It is like a charge which you carry in your pocket that you will place it various places in the diagram to check that how much is the force here, how much is the force there. So it is not a permanent charge. Okay, so in the first
Okay,
diagram
sir.
there are only two charges, one at A and C, and in the second diagram also there are only two charges, one at A and C. The test charge is just used because the word is the test, right? It is only there to test the value of electric charge, electric force at various points.
Okay, sir.
Okay. Yeah. So again, I mean, maybe not this word test charge is new because in the school you may not have any questions like this. But yeah, I hope this is clear. Okay, so now x is equal to 12 or x equal to 2. But if you look at the diagram, x equal to 12 is not possible, right? Because see, what is x? X is the distance between B and C. So how can it be greater than 6? So it has to be smaller than 6. So the only possibility is that x is equal to 2. Okay, so if x is equal to 2, then what the diagram looks like is like this. So A is here, C is here, uh, B is here, D is here. Okay, then this distance is 6, this is 2, and again this is 6 because how BD is given as 8, right? So this is what the diagram looks like. Okay, and what we have to find is find the value of K. That we can do from this equation now, right? So here if I put the value of x equal to 2, I'm going to get K is equal to 14 minus 2 square equal
Sir,
to,
how is AB 6?
oh sorry, AB is 4, not 6, right? Yeah, sorry, it has to be, no, wait. Um, okay, sorry, oh sorry, AB is 4. Yes, AB is 4, this is 2, and this is 6. Okay, sorry. Yeah, but anyway, I mean, we don't need to find the length of AB, but so if I allow find this ratio 14 minus x upon 8 minus x square, it is 144 upon 36, which is 4. Okay, so the answer is k is equal to 4. Okay, so I think again, which is not very different from the questions we have done so far. Like basically, we have two configurations where we are comparing the net force at various positions. Maybe just the word test charge is new to you, but hopefully now you understand how to apply that. Okay, any other doubts about this question? Yes, Atharva.
So can they ask a question in which the net force is not zero?
They can ask if the net force is not zero, but then they have to give the value of the charge, right? Because then whether the charge at B is positive or negative, and how much is the value of that charge, all those things will matter. Only when the net force is zero, then the word test charge makes sense. Okay. Like if you go back to one of the previous question, there they had given the value when the net force was involved, right? If I go back to that question. There they had given the value of the actual charge. Yeah, if you remember this question, if you see here the net force at they are given F1 there. It is observed that the net electrostatic force on the charge is F1. So there the value of the charge was given as minus QB coulomb. So they have to give that value. Otherwise you cannot make any statement. Okay. Okay, then let's go to the next question. Okay. Any ideas how to solve this question 5? So I mean before even doing this question, because here there are two light sources and they are both given as point light sources, right? Last time we discussed when we are talking about umbra and penumbra, that when you have a point light source, there is no question of umbra and penumbra, right? So for the moment, let us say ignore one of the light sources. Okay, let me simplify the question and let us say there is only one light source. Okay, so this is the screen. This is the object. Like this is a square object. Let me draw the screen slightly bigger. Okay, and let us say there is only one light source. Okay, and it is given at, so the important information is the distance between the wall, the object, and the light source is all equal. Okay, so let us say that is given, that the distance between the wall and this, so all the distances are 1 meter. Okay, so my first question is that if this light source is there, what will the shadow look like on the screen? Can somebody tell? So this is where slightly a three-dimensional imagination is important. That in a 3D, can you imagine this? That there is a wall behind, there is a square object, and there is a light source. Then what will happen? How will the shadow look like?
A
Will
cone
it be a
circle.
circle? It will not be a circle, right? It will be a square, right?
I'm not sure, sir, but the same as the square sheet.
Okay, but will it be exactly the same? So if my square is of length 1 meter, so will the shadow will also be 1 meter?
No, sir.
It has to be larger, right? Because what is happening? The light rays are diverging, right? The top will go above and the bottom will go below, right? So it will be like a magnifying effect. So the the shadow will be larger than the object. Okay. So very roughly, like my diagram is not very accurate, but if I roughly draw the corners of my square and see where they are going, then I'm going to get a shadow like. And so how much will be the size of this square? on the shadow? Can somebody estimate how much will that be?
So 2.
2, right? Because basically, why it will be 2? Because this is the midpoint, right? This is like, so from here to here, how much distance was traveled? We are traveling the double the distance to reach the wall. Okay, so like this length line segment of 1 meter will get magnified into 2 meters, and so same will happen for all the four sides. So therefore, this is a square of size 2 cross 2. Okay, and this is completely dark because right now there is only one light source. So therefore, this, so if I call this my light source L1 in the diagram, then this red part is the shadow from this light source L. Okay, now there is one more light source L2 is there. Okay, so let me draw another light source L2 with a different color. Okay, and this new light source L2 over here is, will it also cast a shadow on the wall which is also of a square? So the, if I move this position of L1, like it can be anywhere, the shadow will remain a square, only the position will change, right? So from here the shadow will go somewhere like this. Okay, so these 4 points are going to form the square shadow of L2. Okay, so see, the thing is that if you move the light down, the shadow will move up, right? Do you see this relation, that if the light source moves downwards, then the shadow will move upwards? Okay, but it will move exactly by 1 meter, because if this distance is 1 meter, which is given in the question, right? So if I move the light down by 1 meter, what happens to, like, just look at one individual light ray. Let us say focus on just this top left corner. Okay, like just look at the two light rays which are passing through that corner. Okay, so this was the original light ray, and after I move the light from L1 to L2, this is the new light ray. Okay, so my diagram is not to scale, so it doesn't look like that. But if this distance is 1 meter, then this distance also be 1 meter. So my entire, this red square and the blue square are just offset by 1 meter. And now in this process, like which part of the screen is completely dark, the which is the part which is common to both the shadows, right? So this part in between, this is like, we cannot technically, the amra will not be the right word, but something like the amra, right? So this is the amra, which is completely dark, which is where none of the two light source can reach. And whereas the area around that, right, below and above, this part will be like the penumbra, like this. I don't know if it is visible. I'm shading it with pink. Okay, so this part below and the part above, where only one of the two light sources is able to reach. So that is like the penumbra. And so what is the question asking us to calculate? Find the region which is completely dark. So can you tell me what is this shape which is completely dark? It is a rectangle, right? So it is a
Rectangle.
rectangle of length 1 cross 2. So therefore the area is 2 square centimeter. Oh, sorry, 2 square meter. Okay, and so the answer is 2. Okay, I think, for many of these questions, it is very important that you do lots of experiments. Go to your physics lab in school. I'm sure you must have some apparatus like, light sources, light bulbs, screen, wall, and see like how, when I move the light source, how does the shadow change? Yes, Prasanna.
Sir, if we replace the what we say point source of light with any object, then what would be the area?
So if L1 and L2 are not point sources, but they are, let's say it is, the light themselves has some dimension, then the question will be much more complicated to analyze, because what will happen? L1 will have its own umbra and penumbra, L2 will have its own umbra and penumbra, and then you'll have to intersect the umbra of both of them. So I think it will be difficult to analyze that in a short time. But maybe from very specific case, you can write the equations and see what will happen. But in general, it will be very difficult to analyze.
Okay, sir.
Okay, in fact, after we are done today, if you have some time, I would like to show this in one software called Blender, where so it's actually a graphics software which is typically used for animation and things like that. But as you know, in cartoons and games and things like that, typically lighting is very important. So this Blender software has full support for this kind of lighting and this kind of animation kind of. So we can actually do some experiments in this Blender software. Like for example, if you are seeing what I'm doing here, so this is my, let us say this is my screen, and I add one object over here. Okay, and let me switch to render. Yeah. So you see, so this object at the top, this is the light source, and so are you able to see this? That as I move the light source, the shadow is moving, or if I move the object, if I move the object closer to the light source, then the shadow becomes larger and larger. And so in fact, we can set up the what we are that we are doing. Let us set it up accurately. So suppose the object is here, the light source is here. Okay, so this is the light source, and you see roughly, are you able to see that in the top diagram, compared to the size of the object, the shadow is roughly twice as large. So if the imagine the object is 1 cross 1, then the shadow is 2 cross 2. So which is exactly what we want. Now let us duplicate the light source. Okay, so now I have one more light source, and which is placed at some distance. Now if you see on the ground, are you able to see two different shadows? That so the part which is in the between is the like the umbra, right? If you see, so this is the umbra where both the squares are overlapping, and that is like a rectangle. And on the side, you are seeing this extra areas. So these are like the penumbra where only one of the light sources is able to reach. And so this is very interesting software where you can do all of these experiments. You can have as many light sources of and various objects and see the effect that how you get umbra and penumbra. So yeah, maybe I will talk more about this later. Okay. Anyway, so this was question 5. Then let's go to the next question. Okay, question 6. Any ideas? Okay, so the diagram looks complicated, right? So many resistances, and we only know two things, that how to calculate series and parallel resistances. And right now it is not clear at all where to start also. Like which there are, I don't see any two resistors which are in series or in parallel directly. There is something complicated is going on. So how do you solve a question like this? So there is one small trick involved in this question, after which it becomes very easy to solve. Uh, and that is, observe one very important property about this diagram. Okay. Uh, I have drawn the diagram very roughly here, but the very important property of this diagram called symmetry. Okay, symmetry is a very important concept in lots of physics actually. Okay, so what meaning of symmetry here? Like let us ignore the battery for a moment. Just look at the circuit itself. Then you see that the circuit has a, if I can draw a line like this, right? Then in this line, this diagram is like a mirror image of itself, right? If I if I take the mirror image of the diagram, then it will be look exactly identical to the original diagram. Like if I reflect it, if I look at the diagram in the mirror, won't the reflection look exactly the same? Okay.
Yes, sir.
So, so if the mirror image is the same, then can it be that the left this resistance, if I, let's say, how much current flows to this resistance and how much current flows to this resistance? Can it be that 1 ampere goes here and 10 amperes comes here? That doesn't make any sense, right? If it is a mirror image, then if this happens, then it means that whether you look at a diagram from the left or the right, your answer is changing. That here in this part, in this version, this is 1 and 10 ampere. But if you take a mirror image, now the answer is 10 ampere and 1 ampere. That cannot happen, right? So the only possibility is that both these resistances have the same current. Okay, so if I so focusing on these two resistances, if I call them maybe X and Y, so the symmetry gives me the property that resistances X and Y resistances should have the same current flowing through them. Okay, so and current, you can imagine like water. When water flows through a pipe, right? Suppose you have pipes which are joined at some location. Like if you look at this top point, right, where three wires are joined, right? So we have this left X, Y, and let us say this resistance is Z. Okay, so this X, Y, Z, all these three pipes are joined over here. Okay, and if I'm saying that water flows here, like water current flows here, same current flows here, then how much current will flow through the middle pipe?
Sir, zero.
Zero, right? Otherwise, so basic law that you are not going to create water or you cannot destroy water. So if 1 liter of water flows through here and 1 liter comes out, then there can be no water flows through this. So in other words, this resistance has no current. Okay, in my diagram, in the right diagram, this resistance has no current, which means I can ignore this resistance completely. It is as if it is not there at all. Okay, I will explain this part once more, but hopefully if you understood this, then now look at the new diagram where I have deleted this resistance completely. And now are you able to solve it? Now what do you see? And what is given is all the resistance are 10 ohm. Okay, so now what can we do? Can we solve this now with normal techniques?
Yes, sir.
Yes, right? Because now what is going to happen? This top part, this is just a series of 10 plus 10, 20. This is also 10 plus 10, 20. So therefore now this circuit is equivalent to 20, 20, and the bottom one will remain 10. So now all of these three are in parallel, 20, 20, and 10. And now this we know how to solve with the parallel resistance formula. So you see, once that middle resistance got deleted, then the diagram is suddenly very easy to analyze. Okay, and then the answer will be just so the total resistance will be just 1 over 20 plus 1 over 20 plus 1 over 10, which is 1 over 5. Therefore, the total equivalent resistance is 5 ohms, and then the battery has 100 volts, so therefore the current will be 100 upon 5, 20 amperes. Okay, so all of this was enabled by this one simple observation of symmetry. Okay, so you see, you are starting to see examples that how we expect you to think outside the box. That don't just go with the basic knowledge, but observe this pattern that because of symmetry. So let me repeat again what I said, that because of symmetry, this left and right resistance should have the same current flowing through it, and current does not get created or destroyed. If some current is flowing inside this node, it has to flow outside from somewhere. And if all of it is going to flow outside from the right side, then there is nothing left in the middle. So therefore, that middle resistance we can completely ignore. Okay, and therefore we are able to simplify the diagram. Okay, I'll just give you 1 minute to think and ask any other questions about this.
Sir, this can be also solved by using Wheatstone bridge.
Yes, it can be solved using Wheatstone bridge, correct? But I guess everybody has not studied Wheatstone bridge, so this approach hopefully everybody understands. But yes, in your 11th standard, if you are going to take up electronics, you will learn about this Wheatstone bridge very quickly. Okay, if no other questions, then let's go to the next question. Okay, question 7. Anybody has solved question 7?
Yes, sir.
Yes, sir.
Yes. Okay. What is the answer?
50.
50, right? Yes. Yeah. Again, I think this is pretty much all the concept we have used before for this kind of questions. We can use it here also. So we have ice at 0 degrees and metal at 340 degrees. Only thing is we don't know how much quantity is there. So we have to assume, let us say there are X grams of ice, and then because the total mass is given as 100 grams. So therefore, if X grams of ice, then 100 minus X is the metal, right? And then the whole system reaches, so the equilibrium temperature is given as 40 degrees, which means the ice will melt into water, and then the water will will raise its temperature to 40 degrees, and the metal will directly cool down from 340 to 40 degrees. So everything comes to 40 degrees. So therefore, what is the heat lost by the metal in this process will be simply the specific heat capacity of the metal, which is 0.4 into the mass of the metal and into the temperature difference, which is 340 minus 40, so 300. So this is the number of calories of heat lost by the metal, and the heat gained by the ice slash water. So first we have to consider the latent heat to convert the ice into water. So that will be 80 calories into the mass of the ice, and then after that going from 0 degrees to 40 degrees. So that will be a temperature difference of 40 into specific heat capacity of water is 1, and again the mass of the ice. And so these two have to be equal, right? And so I think we can directly solve it. Doesn't we get 120 to 100 minus x equal to 120x, and therefore 100 minus okay. So basically, which means that exactly 50 grams of ice and 50 grams of metal are there originally. Okay, again, this is definitely one of the simpler questions. So, so by the way, one more thing I want you to observe about this paper. You see that it is not that the difficulty level is uniformly increasing. That the first question was easy, then medium, then hard. Suddenly, between hard questions, some easy question can come like this. And so, one very important thing which you need to learn is time management. Okay? Okay. If you let's say that some student spends a lot of time on the hard question, that somebody got stuck on question 6, and then they did not get enough time to do the next remaining question, then you are losing on the marks, or you might in a hurry you might make some calculation mistakes. So planning your time is very important. That make sure you attempt all the questions, like don't leave any question because of short time. So like plan your 1 hour properly, that how much time you want to spend on each question. After a while you move on. That if you're not making any progress after a few minutes, then skip the question, come back to it later. But plan your time properly. That will make a lot of difference. Okay, and
Sir,
because
is there any reading time allotted to the paper?
reading time, no, I have not heard of this. I think whatever time is given to is the time available.
Okay.
Yes. So by the way, some students, because as you know, this is a 00 to 99 kind of, you have to fill the bubble sheet, right? You have the bubbles on the answer sheet where for the digit 0, 1, 2 up to 9 for the tens place and the units place, and you need to darken the circles. So for example, if the answer is 12, then you will darken 1 and 2. It takes a few seconds to do that for every question. So different students have different ideas. So some students they will not do the bubble sheet marking immediately. They will just write the answers in rough on the question paper, and then the last 5 minutes they will use to fill up the bubble sheet. That is also fine. Or you can continue as you go along. Every time you solve a question, immediately you fill in the answer. Or sometimes some question you are not confident about the answer. Maybe you want to recheck your calculations. So in that case, you will skip that question and fill the answer at the end. So like all of these approaches are possible. Only one thing, don't make this mistake. Often what happens is question 1, question 2, question 3, they all have their bubble, like the place. So, you know, planning your time is very important. That make sure you attempt all the questions. Like don't leave any question because of short time. So plan your time properly. That will make a lot of difference. Okay, and because
Sir, is there any reading time allotted to the paper?
Suppose you solve question 1, you mark the bubble answer. You try question 2, you did not get it, so you skip question 2. Then you solve question 3 and you fill the answer, but while filling question 3 answer, you accidentally filled it in bubble for the question 2's place. So your question 3 answer accidentally you wrote in question 2. Then and you will continue this mistake. Question 4 you will write in question 3. And like that mistake will carry forward for 3-4 questions. And then once you realize, then basically all of your answers are wrong now. Now everything is misaligned. So don't create this kind of confusion. Okay. So if you are skipping a question 2, remember that you have skipped that question and write question 3 and under question 3 only. And this might seem like a trivial mistake. You think that it is impossible to make this mistake, but you will be surprised how many students have this problem.
Yes, sir, I
So yeah.
made the same mistake, but only with one question.
Okay, that is better than, if you reach the last question and you realize, okay, there is one empty gap, then it will be a disaster. I don't know, sometimes they allow some way to correct your answer, like if you make a wrong answer, like make a cross and make another bubble somewhere else, but I don't remember the exact. And the thing is, this is computerized, so if the computer does not read your marks correctly, and you will lose it. So yeah, make sure to spend enough time to do it correctly. Okay, anyway, so that was question 7. I will go to question 8. Anybody who has solved question 8?
So what's the answer?
Yes, sir.
Answer is 40 joules. Is that correct?
Yes, sir.
Yes, I got it.
Yes, sir.
So can I try?
Okay, I think yes, go ahead.
So kinetic energy of B would be half mv square,
Yes, okay.
and its m is 10 and its velocity is 3, so it will be 45 joules.
Yes, okay.
And kinetic energy of A would be 5 joules the same way, and then we
Yeah.
lost kb minus ka, and so we get it.
Oh wait, but I mean, after the blocks collide, what happens?
So they move
The
together.
Okay, but then what is the new kinetic energy? Because the question is how much kinetic energy we'll have later on.
So it's just the loss of kinetic energy, no?
Yes, correct, correct. So okay, we are saying after the collision, the energy is 5 joules, and initially it was 45. That is what you said, right? Or I'm not sure how. What is the calculation you're doing?
Sir,
Yes.
the momentum would get conserved, and the momentum for B is 30. For
Yes.
A, it's 20. For A, it's 10.
Yes.
And they are
But
in opposite direction.
yes, correct.
And they are in opposite directions. So it's 30 minus 10, that is 20.
Correct.
20 towards right.
Yes, correct.
And the combined mass would be 20 kg, and it is acted upon by 20 units of momentum. That therefore
Yes.
the combined object would move at 1 meters per second, and
Yes.
that would have a kinetic energy of 10.
Yes. Okay. And the
uh,
original kinetic energy was 50, right?
50.
Yeah, correct. Yes, correct.
But sir, I still have a doubt in this question, and that is,
Okay.
energy cannot be lost nor can it be created, right? So what do we mean
Yes.
when we say energy is lost, kinetic energy is
Okay.
lost?
Yeah. Okay. Okay. I will explain that. But yeah, before that, just to complete the calculations for everybody. So yeah, I mean, so the object let us assume the convention that right is positive and left is negative. Okay. So that the signs will help us. So therefore, if A is moving to the left, so its velocity is -1 meter per second, and B is moving to the right, so its velocity is +3 meter per second. So the total momentum initially, so initial momentum of the system is and the weight is 10 kg for both, so it will be 10 into 3 plus 10 into -1, so which is 20. And what is the units of momentum? Kg meters per second, and this is +20. Okay, so there's net momentum towards the right. And now final momentum, like after the collision, the combined mass is now 20 kg. And so if I don't know velocity, if I just call it as v, then the final momentum, which will also be equal to 20, will have to be equal to the weight 20 kg into v. So therefore v is plus 1 meter per second. So the object is moving to the right. Okay. And now, so the initial kinetic energy, like the total kinetic energy of the system was half mv square for both A and B. So half into 10 into 3 square and half into 10 into 1 square. And so that is 45 plus 5, which is 50 joules. And the final kinetic energy is half into 20 into 1 square, which is 10 joules. So therefore, from here to here, the loss of kinetic energy is 40 joules. Okay, so yes, so now the question is, where did this energy go? Because as Sri Shiv said correctly, that energy cannot be created nor destroyed. So this energy must have gone somewhere, right? So it actually got used up in the process of collision itself, because uh, real world objects are not perfect. Like when two objects collide, like imagine that you have a ball which you throw on the table, or just if you release a ball from your hand and let it fall on the table, so it will bounce and it will bounce back. But does it bounce to the same height as you dropped it? It will come back, but typically it will be slightly lower, right? And so it will continue bouncing, and every time it goes down, it will come back to slightly larger height. It's like that, it will continue to bounce finally until finally it comes to a stop on the table. So like that, with every single bounce, it is losing some energy in the process of collision. And when the collision is happening with the table, then there is some friction involved. Like if it's a rubber ball, then the rubber and the table, they will have some friction, and in that process, the typically the energy is released as heat. Okay? So if you do this for a really long time, you will in fact observe that the rubber ball becomes slightly warmer. Okay, so the loss of energy is in the form of heat and friction typically. Okay, and so and this happens so in the real world, all the collisions are called inelastic collision. Okay, because of this loss of energy, so it is called an inelastic collision. Sometimes in physics problems we make an approximation and we say it is an elastic collision. If I say a collision is elastic, then I'm saying that there is no loss of kinetic energy. Okay, so in a perfectly elastic collision, this ball will continue to bounce to the same height, that no matter how many times I drop it on the table, every time it will come back to the same height, because it is not losing energy at all. But of course, in real world, this never happens. Okay, does this clarify? Yes, Atharva?
So where is this perfectly elastic collision possible?
In real life, I think it is never possible. I think any two real surfaces, when they collide, and by the way, one more thing happens, very subtle deformation happens. Like if I zoom into the point of the collision, right? So before collision, the ball may look something like this. At the point of collision, right? And we think that collision happens instantaneously, but actually there is a small fraction of the time for which, so the ball just touches the table here, and in fact, it will get slightly deformed. So for a very brief fraction, the ball is not a sphere, but is like a slightly compressed. Like if it's a rubber, rubber you can slightly compress with your hand. So for a small fraction of time, it is not just the the tip of that contact, but there is a whole surface which is there is in contact, and during that time, because of friction, the energy loss happens. I don't think it is possible to avoid the loss of energy like that. Yeah, I never seen that how. So there are lots of things can be done to reduce the loss of energy to make it as close to elastic. And you must have seen this, right? Different balls are different uh, bounceability. I don't know. So if let's say cricket ball may behave differently compared to a rubber ball or a tennis ball. So each ball will have slightly different. So there is a coefficient of this elasticity, that how much energy is lost, that is given by some coefficient. And if that coefficient is less than 1, I mean, it is always less than 1, because always you lose some energy. Okay. But you are going to learn about all of these things in much more detail in your 11th and 12th standard. Okay, any other questions? So in fact, if you take a very high speed camera, right, and you are able to watch this effect in slow motion, you will observe this deformation, that how the ball slightly, so initially the ball looks like this, then for a brief moment the ball compresses like a spring, if you push a spring it compresses, and then from that compression again it will bounce back to the original shape, but during that small fraction of interaction it has lost some energy. And I think maybe you can show on YouTube, you will find some videos like they use really high speed cameras to capture this motion, and you will see this effect actually. Okay, then let me go to the next question.
Sir,
Yes.
for the next question is the answer 33.
33. No, 33 is the distance between the lenses, right? I think the
Ah, but
focal length is 6.
Centimeter.
I got the answer as 6. Is that matching with anybody?
okay, sir, no problem. I got it wrong.
Okay. Okay. But any suggestions how to do this question?
Yes, sir.
Okay, just a minute. Let me draw the diagram. Yes, Prasanna.
Sir, I have that suggestion of that how to solve.
Okay, tell me.
Sir, image distance of that first refraction would be equal to the object distance of the second refraction.
Why?
No, sir, their addition would be 33.
Yeah, the addition will be 33. That is correct. Correct. Okay, so let us give some names to the variables. Let us say this is x and this is y. So therefore, I can say x plus y is 33. Okay, and what can I do after that? Anybody else? Shrish, you want to, or yeah, Prasanna, you can tell.
Sir, magnification we can find and then find object distance and image distance.
Yes, correct. Yes. So let us take the left half first. So focusing on the left lens. So the object that was 8 centimeters, it became 12. And so here, if you see the similar triangles, which we have done before also. So this distance can be related to x, right? So if I call this u, then u upon x will be equal to the ratio of the object sizes, right? 8 upon 12. So therefore, u can be written as simply 8 upon 12x, or that is 2 upon 3x, right? So this is simply 2/3 of x. And similarly here, if I call this distance as v, then here also you see the magnification on the second lens. So this the y upon v has to be equal to 12 upon 6. So therefore v will be y into 6 by 12, or in other words y by 2. Okay, so this the object distance at the start and the last image distance, all of them can be written in terms of x and y. And now we just write the lens equation, right? So the focal length of both the lenses is given as f, or I mean we don't know that, and so that therefore for the first pair we have to write 1 over u plus 1 over x is equal to 1 over f. And again here directly I can write the Gaussian equation without worrying about the signs, because everything is positive. And so instead of x I can write sorry, instead of u I can write 2 by 3x, right? So this will become 3 by 2x. Okay, this is my first equation. And on the right hand side I will get a similar equation. Now this time this image is the object, right? So therefore y and v, so 1 upon y plus 1 upon v is 1 upon f, and again I can replace v by y upon 2. Okay, and the third equation which I know is the x and y are themselves, the sum is 33. So all this together should be able to solve the equation. So let me simplify the two parts. Sorry. Okay, so if I equate these two directly, I'm going to get 5 upon 2x is equal to 3 upon y. In other words, 5y is equal to 6x. and also x plus y is 33. Okay, so in other words, if I write this ratio, then x upon y is equal to 5 upon 6. Okay, so I have to take 33 and split it into the ratio 5 is to 6, right? So if I have a object of length 33 and I have to split it as 5 is to 6, then so the total is 11 parts, and so therefore this has to be 15 and 18, right? So x is 15 and y is 18. And so if we put this back into the original equation, we want to find the value of f. So you can do it from, let's say, from this equation. So here, because y is 18, so 1 upon f is 3 upon 18, which is 1 by 6. So therefore f is 6. Okay, so again, this is mostly just calculation based question. There is not much physics theory to be applied here. Just observing two things, that because of the magnification, like we know the ratio of the object and the image sizes, we can relate these distances with like this kind of formulae, and we did that on both the sides, and then just solving the lens equation for both the lenses separately. Okay, any doubts? Okay, not then. Last question, question 10. Okay, so what is happening in question 10? So that it is a bit of a trick question if you're not careful, because see the what it says, after 5 seconds both the objects have traveled the same distance. You know, the word is distance, not displacement. Like typically when we write kinematics equation, we are always thinking about displacement, but here we are talking about distance, which is a scalar quantity, right? And I think you must be already aware of the difference between distance and displacement. Like suppose an object travels like this. Okay, it goes 10 centimeters here, and after that it comes back 5 centimeters. Okay, so then how much is the displacement? Displacement is 5 centimeters, but the distance traveled is 15. So the distance traveled will has to take into account the total path of the object. Okay, so we are talking about distance here, not displacement in this question. Okay, and typically we don't have any direct formula for distance, right? In kinematics equation, that s is equal to ut plus half at square, that s is only the displacement. You don't have any formula for distance. Okay, but in a this is a very simple situation where it is possible to find a distance. Okay, if we draw the diagrams correctly, we can see that what the distance is going to be. Okay, so let me draw the diagram of, so initial picture at t is equal to 0 is like this, that object A and B are at the same position, except object A is dropped to the ground and object B is thrown upwards. Okay, but of course both of them will have gravity acting on it, and after 5 seconds, what will happen, that B will have traveled some distance. We don't know where B is now, but let us say it is here. So starting from the original position, B has traveled this much, and where A has fallen down by some distance. Okay, and up to this point, both of them have traveled the same distance, is what we are saying. So now, when will this happen? That when will both A and B have the same distance covered? So first question. See, initially A is at zero velocity, right? and B is at velocity v, which means initially A is covering no distance. Like if at the very start A is covering no distance, whereas B is covering distance of v meter per second. So let me draw it as a graph. Okay. So A's trajectory looks something like this. That initially A starts with like a flat line, but slowly A will pick up speed, whereas B already has some speed when it starts. So therefore, in the first, let's say only the first 1 second, can you tell me which of the two objects have traveled more distance, A or B? The
B.
very initial B, right? Because B already has velocity. So initially, it cannot be that B has like they have the same distance. So initially, they will necessarily have unequal distance. That B will have more coverage than A. But slowly, what is happening is B is slowing down. B is slowing down, whereas A is speeding up, right? So as the velocity of B decreases and velocity of A increases, slowly the distance covered by B in 1 unit time will be lesser and lesser, whereas the distance covered by A will be more and more. Okay, but now consider the point where let us say B comes to a complete stop. Okay, so at the moment we don't know when that will happen. Okay, but assume that after some seconds, okay, after some seconds B has come to a complete stop, which means now the velocity of B is 0. Okay, and initially the velocity was v, right? So first question is, after how many seconds will this happen? Like if I find the time over here, how much will the time be? Can somebody tell me? How will you find how much time it will take for the velocity to become completely 0?
Sir, by taking v is equal to 0 means final velocity
Yeah, correct. Yeah, correct, right? So basically v is equal
and
to u plus 80,
substituting
right?
that into v is equal to u plus 80.
Yeah, correct. So because the gravity is g, right? So therefore basically the change on velocity, right? The change in velocity has to be equal to gravity times time. Okay, so therefore t is nothing but v upon g. Okay, so basically after v upon g seconds, the first object will come to complete stop. And at this very moment, can you tell me how much is the velocity of A? Because A started at 0 velocity. So in this much time, how much velocity will A pick up?
Sir, gt.
GT, right? But GT is V. So which means initially B was at velocity V and A was at velocity 0. And after this much time, now B is at 0 and A is at velocity V. So you see some kind of mirror image is happening. Again, if you remember that word symmetry that we seen before, that it is almost like A and B have reversed their like what A was doing now B is doing, and now B is doing what A was doing. Okay, so the roles are now interchanged. But in this process, what has happened is that, so let us write the displacement, like how much. So how much displacement of B from 0 to V by G will be given by the formula ut plus half at square. So V into T, which is V by G, minus by minus again because it is gravity. Gravity is always pulling down, half into G into T square. So this is the displacement of B. But that is also same as the distance of B, right? Because right now, because B was already traveling upwards, so in this direction, the distance and displacement are not two different things. This is also the distance. Okay. And for A, if I write the formula, then it is that so the displacement of A is from here to here, so it is ut. So 0 minus half into G into T square. Okay, so if I simplify this, Okay, so the distance traveled by the displacement or the distance which is the same for B is v square upon 2g, whereas for A the displacement is minus v square upon 2. So if you see the sign is opposite, the sign is opposite because they're traveling different directions, right? B is traveling upwards, so obviously its displacement is positive, and A is traveling downwards, so its displacement is negative. But because the question is asking about distance, not displacement, so can I say that they have both traveled the same distance? Because distance is just the magnitude, right? So up to V over G, A and B have traveled the same distance. And what the question is saying, at after 5 seconds, both objects have traveled the same distance. In other words, that time given 5 seconds is exactly this moment, okay? When the object has come to a complete stop, like when B came to a complete stop. So that was exactly the point where this is going to happen. And now, therefore, now can I calculate V now? So V is just 5 into G, which is 50. So the answer is 50. Okay, let me explain this again. So initially, when the objects were starting, B had the velocity V, and A was stationary. After this time, B has the velocity 0, so B has come to a complete stop, but A has picked up velocity of V. And in this process, if I just write the kinematics equation for both A and B, and I write them as displacement, they have different signs, but the magnitude is the same, correct? So because the magnitude is the same, therefore that was exactly the moment that we are looking for, which is 5 seconds. And therefore V upon G is 5, and therefore V is 50. Okay. Now somebody may have the question that, what if this keeps happening, that at this moment, maybe you agree that after 5 seconds, the both objects have the covered the same distance. But what if, if you continue to play the tape further, now B will start falling down and A will continue to fall. Maybe after some more time, again they have covered the same distance. Is that possible? That let's say after a few more seconds, again the total distance covered by B and A is identical. Can that happen or can that not happen? What do you think?
So I guess as we have got only one value of time, so it won't happen.
Yes, correct. But I would offer a different explanation why this will not happen. You see, something very interesting is happening at this point. See, right now B is stationary. At this point, the velocity of B is 0. So the path that B is going to take from this point onwards, isn't it the same path that A has taken? But except now B is starting late. So you see, A had already started earlier, but B is going to start late. So from this point onwards, A will always have more coverage than B. See, right now at this point already A has velocity V, whereas B is stationary. So every second that passes, A will be faster and faster than B. So it will never happen that the total distance is again the same. Right? Like imagine that there are two objects where one is traveling faster than the other object. Okay. Then the object which is faster will always cover more distance than the slower object, right? So their distances will never be equal. So therefore, from this point onward, this can never happen. That again the distances will match. That is impossible. But I would encourage you as homework to try to write the equation. That suppose I take some point capital T. Okay. So at t is equal to capital T, I would encourage you to write the distance traveled by B and distance traveled by A, and check that how always A has more distance than B. Okay, it is possible to write the mathematics and check that. Okay, as a homework, I would suggest try this. But intuitively, I hope you understand that why A will always have more distance than B from this point onwards. So this was the first and the last point where the distances of A and B are matching, and that is exactly the 5 seconds which is given in the question. Okay, so this is an example of question where I will say is very much about the physics concept, that you cannot do this by just applying formulae. You have to really understand well the physics part of it. Whereas the previous question I would say is much more about the mathematics, that you just apply the lens equation and you get it. You don't have to have much theoretical understanding of physics. So like that, every question is different. Some question requires you to really know the physics well. Like I would say this question, like this is where you need to really understand what is current, what do you mean by current flows through one wire and into the other wire, and all those things. But some question like the specific heat capacity requires some little bit understanding of latent heat, but not much. So like that, every question has a different mix of theory and calculation. So use that also as a sort of a metric, that how much are you able to appreciate physics? Are you able to do just the calculation questions, or you're able to do these conceptual questions also? Okay. Of course, this is very early to judge this, but all of this will help you in your future decisions. That when you are going to join engineering in any stream, which branch you want to choose? Do you want to go for electrical engineering, mechanical engineering, computer science? Each department has a different requirement of mathematics and physics. So understanding this is very important. That what is it that you are able to understand and apply properly. Can you send more practice sheet other than the previous papers? I don't have any other material actually, because so last year we were not preparing any practice material. Only this year we started actually. So, but I will suggest some problem sources. And honestly, what is the best problem source? I I This is a new discovery for me. Uh, ChatGPT. So you ask ChatGPT that I want more practice, and it will give you more practice. Uh, so actually, I would like to very much conduct a separate program for all the students. I want to show you that how to use ChatGPT to really be your AI assistant. That how you can use it to improve your problem solving. Just to give an example, that this is not just a theoretical thing, that I can actually use ChatGPT to do some interesting things. So I don't know if you know this, but I am not in India, so I am in Germany, and so because I am in Germany, I have to learn German, right? So I use ChatGPT for all my learning. That I ask it questions. That, for example, I ask it to give me practice material. That I want to write a letter, so give me some topic. So it will suggest a topic to me. That this is the topic. Then I write my letter, and then I ask it to correct my letter. Then it gives me the correction. That what are the mistakes I did in my letter. So you can do that for mathematics also. I tried it for physics. I asked. So you see what I've done here. I asked that last question here. So that was exactly what I asked. The empty cylindrical glass of height 20 centimeter floats in water. This is exactly the question that we did today. So I asked ChatGPT that can you solve this question for me? So it solved the question. It gave me the right answer, 15 centimeters. Then I asked the question which I asked you also, that what is the general principle? Will this always happen? So it gives the right answer, that the amount of the glass that is submerged is equal to the amount of water that you add. And then I asked the same question which you asked, that what if I use a liquid which is not of the same density? Then it gave me the answer to that. And so if you want more practice, I can ask it. Uh, Let us see what it gives me. That is, you wanted one more question. This is one more question. Okay, but just like any other tool, it has to be used with proper understanding, that what are the strengths and weaknesses of a tool like that. You don't want it to destroy your thinking ability completely, right? So you want to use it responsibly. But certainly, these are some very new, interesting times that we live in, and we should take full advantage of these capabilities. Okay. Uh, I think that's all from me. Any other topic that you would like me to talk about?
So can you explain penumbra and umbra in short?
Okay, sure. So in fact, uh, because we have time, let me actually show it in that other software. Okay. So let us say I have a this is my the screen, and I have some object, like for simplicity, I'm let us take a circle. Okay. Okay, so this is my circle, and where is the light source? So this, if you see the top, this is the light source. Okay, and now this is a case where there is a point light source. Okay, so what happens when a point light source is there? You see in the diagram, like if I trace direct light paths from the light source to the object and then to the ground. Okay, let me just move that object slightly. Okay, so here if I trace this light directly, right? So this is like one end of my object, and this is the second end of my object. So here, if you see in this part, right, there is no light reaching from my light source, right? So this part is completely dark, and so this is what I call the umbra. Okay, and in this case there is no penumbra, because the rest of the image, if you see, is completely illuminated, right? Every other point is directly visible from the light source. So therefore, there is only umbra if my light source is a single point like this. Okay, but now if I change the light source, okay, so let me delete this light source and add a new light, which is a area light. Okay, okay, so what is the meaning of an area light? That the light source is itself, if you see, it is a small square. Okay, so which means the light source will also cast a, if you see here, like here, if you see that light source has some width and height. And let me increase the power of the light source. Okay, and also let me increase the size of the light source a little bit. Okay, and now if you see on the ground, what is happening? You see on the ground, now I'm getting two different regions. So there is a region over here which is the same as before. So this is the umbra, but now there is a second ring here where only some of the light is reaching. So like if I were to trace the paths of the light, right? So then if I were to trace, if you take one end of my light source and trace it directly like this is still the umbra. So any point here, just take any point over here, and you see that there is no way to go from this point to the light source without passing through the object, which is not allowed, right? Because the object is opaque. So that is why this part is completely dark. This is the umbra. But the penumbra is the part where from where the light source is partially visible. So from a point over here, if I trace this light path, right? So see, from this point, only this much part of the light source is visible. So you see it is partially illuminated. So therefore, this ring outside is the penumbra. Okay, so this is the umbra and this is the penumbra, and then outside the penumbra is this part, which from this point the entire light source is visible. So therefore, here there is no shadow at all. So these are the three parts, and as I you can see that as I move this object, the side the position of the umbra and penumbra changes, right? So if I let us say the object is very close to the light source, right? Or depending on the size of the light source. If the light source is very small, then the umbra and penumbra are very small. If I increase the size of the light source, you see the penumbra increases more and more. And if I have the reverse situation, let's say the object becomes very small, right? As I'm reducing the size of the object, you see the umbra is becoming smaller and smaller. And one point will come where the light source is only so big that the umbra vanishes. See, look at this. Now there is no umbra, there is only penumbra, because from every point on the wall, some part of the light source is always visible. So there is no part of the screen which is completely dark. Okay, but now if I increase my object slowly, and see there is some noise because this is a software, this is not perfect. So there is some, you see this, याला मराठीत आपण मुंग्या म्हणतो. You see this noise pattern, that is because of the software, but in real life you will see a perfectly clear shadow. Okay, so this is what is called the umbra and penumbra. So is that clear how it works?
Yes, sir. Thank you.
Yes. Okay, any other questions?
Sir, can you explain the concept of buoyancy?
Buoyancy. Okay.
Yes, sir.
Okay. Okay, but anyway, so apart from that, if any other doubts you have, you can let me know. We, for everybody else, in case you don't have any questions, if you want, you can leave. This week you will have your chemistry lectures with Sohani madam. So we will post the link for that for this week, and after that again we will have mathematics. Okay, thank you. Bye. Okay, so buoyancy. Okay, so the first question is that why do we have buoyancy? That the buoyancy is a property that liquids have because if there is some object, let us say there is some, let me not drop the side view, let me drop the view from the front. Let's suppose there is some object which is partially immersed in water, let us say. Then, as I explained some in maybe last lecture or the previous lecture, that the water molecules, they keep moving around and they have what is called pressure. So the pressure is the water molecules which are like, you can imagine they're like small tennis balls, or they are like bouncing on each other as well as the surface of the object, right? So they will keep interacting or hitting the walls of the surface from all directions, and that is what creates some force. And the buoyancy is because, like, basically as you go down into the water, the pressure is more and more. So basically the pressure is maximum at the lower depth and it is less at the top. And if you add the sum total of all of these forces, that is, the net effect is as if the entire object is being pushed upwards, and that is what we call the buoyancy. And the how much is the value of the buoyant force? So because it is because of the molecules of the liquid, right? So the weight of the liquid matters. So but weight of the liquid is measured in terms of the density, right? It is not like one object. So density of the liquid matters. So if I call the density of the liquid as rho, then rho times the gravity times the volume. So how much volume is submerged? So sometimes it is called a submerged volume, sometimes it is called a displaced volume. Same thing. So the mass of the object does not matter. Whether this object is made of wood or plastic or uh, some metal, doesn't matter. Whatever the object is, the how much volume is occupied, that is the only thing that matters for the buoyant force. Okay, but why does the object matter? If the same object also has gravity, then gravity obviously will depend on the mass of the object. So obviously if the object is more dense, then gravity will be stronger, or if the object is lighter, then the gravity is weaker. So what changes is the gravity, not the buoyant force. Okay. So basically when the object is floating, these two forces have to exactly cancel. The buoyant force and the gravity have to exactly cancel. And from that we had derived the equation earlier, that the volume of the displaced or the submerged upon the total volume of the object, this ratio is exactly the ratio of the density of the object upon density of the liquid. Okay, so for example, if the ratio is half, let us say that exactly half of the object is floating like this. which means this ratio of the what is inside the water versus the total volume, this ratio is half, which means that this ratio is also half, which means if the liquid has density of 1 gram per cc, then the object had density of 0.5 gram per cc. And so as long as the object is less dense than water, it will float. As soon as the object is more dense than water, like imagine the object is 2 grams per cc, which means the object is so heavy that even if the entire object is inside water, the volume occupied will generate some buoyant force. Obviously, the buoyant force is there, but the weight of the object is even more. So the object has to sink. So that is what causes the object to sink. And in fact, if you observe this, while sinking also it sinks slowly. If you take a glass of water and you throw an object, if you take a metal ball, okay, and if you drop it normally, it will drop very fast. But as soon as it enters the glass of water, it is sinking, but the speed will reduce. The speed is reducing because now the gravity is somewhat replaced. The effect of the gravity is somewhat countered by the buoyant. So that is why the speed at which the object sinks is lower. But it is not, the buoyant force is not strong enough to completely float the object. That is why the object will sink like a metal ball. Versus that a wooden ball will continue to float because wood is lighter. So therefore, even if a small part of the object is submerged, that much buoyant force is enough to balance the gravity. Okay, is this explanation sufficient?
Okay, sir.
Okay. Okay, I think we are out of time. So yeah, that's all I wanted to cover in physics. I will see you again in the next week after you are done with the chemistry.
Thank you,
Sir,
sir. Bye.
Thank you. Bye.
sir,
Yes.
sir, next week on the first maths class on Thursday, 9th Jan, I have my prelims going on, so I will not be able to attend that one singular class on Thursday. So will I be able to get the recording?
See, right now what we are not sharing the recordings because we would like you to focus on this is like a live classroom session. But do one thing, after all the lectures are done, message us again, then we will see what we can
Okay, sir.
do. Yeah. Okay. Yeah. That's all. Thank you. Bye.